Hello everyone, welcome back to the series on timers, counters and other applications. In the previous two videos, we have taken the timers and explained about the different types of timers. Then we have discussed few application programs on timers. In this present video, we will be discussing about counters, and in the following video, we will be discussing about few application programs on counters. Okay, so first we will start with the counters. So if you consider the counters, basically there are two major types of counters: up counter, down counter and up down counter. These are the three major types of counters. Okay, I will be showing you one by one and I will be explaining them about them. First we will start with the up counter. Next we should, first I will start with the up counter. So if you consider the up counter, this is the up counter input pulse signal that we are giving over here. This is the output of your up counter. R indicates the reset switch. R indicates the reset switch, and PV is the preset value. It is the value for after which the output has to go high. Okay, I'm assigning addresses over here: M0.0, M0.1, and for the output I am taking another address M0.2. Okay, this is my up counter input. This is my up counter reset switch, and this is my up counter output. Okay, first I will try to explain you the working of this up counter. Okay, if you can take the up counter, the input pulse signals are given over here. Initially, the cumulative value will be 0 over here. When we are giving the pulse signals as the input, the cumulative value will increase by 1 unit at a time. And when the cumulative value is greater than or equal to your preset value, your output will be high. Okay, I will try to explain. Please observe carefully. Initially, the cumulative value over here is 0. I have given a pulse signal over here. When I have given a pulse signal, high signal over here, you can observe that the cumulative value is 1. And I have given the low pulse signal. And when I have given another high pulse signal, you can observe that the cumulative value has changed from 1 to 2. Okay, it is less than the preset value and our output is low. When I made the input low again, the cumulative value is 2. And when I made the input high again, the cumulative value is 3, which is equal to the preset value. The output is high. And if I continue to increase the number of inputs, if I continue to give the input signal, pulse signals, the cumulative value will start to increase, and you can observe that it is greater than the preset value. It is greater than the preset value and the output is high. Okay. In order to reset the system, we need to make the reset button high. When we make the reset button high, the system will be reset, the cumulative value will be made equal to 0 and the output will be made low. And once the reset switch is made low, then we can perform the operations. So this is how a typical up counter works. Okay. Now we shall discuss about the down counter. If you consider the down counter, CD is the down counter input, LD is the load option that is present in your down counter, and PV is the preset value. Okay. Q is the output. I am assigning addresses for the down counter. M0.3 as the input, M0.4 as the load, and M0.5 as the output. Okay. Down counter input, down counter load, and down counter output. Okay. I will try to explain. Please listen carefully and understand it. Okay. Now if you consider your down counter, initially you can observe that the load has not been enabled, the cumulative value is 0 and the output is high. Please remember carefully, in the down counter, first when we enable the load, the preset value will be transferred onto the cumulative value. The preset value will be transferred to the cumulative value, and when the cumulative value is 0 or less than 0, the output will be high. That is how the down counter is programmed in the TIA portal software. So initially, first thing that we need to do is load our preset value to the cumulative value. That is done by enabling the load option. When we enable the load option, the preset value is transferred onto the cumulative value. The preset value is transferred onto the cumulative value. Now I have given a pulse signal as an input to the counter. So you can observe that the cumulative value has changed from 3 to 2. Okay. The cumulative value has changed from 3 to 2. Okay. Now I am giving another pulse signal as the input. When I have given another pulse signal as the input, the cumulative value has changed from 2 to 1. Okay. And when I have given another pulse signal as the input, the cumulative value has become equal to 0, which is and how does the down counter work? When the cumulative value is 0 or less than 0, the output will become high. So as the cumulative value is equal to 0, the output is high. And if you are giving further pulse signals again, you can observe that the cumulative value has decreased from 0 to -1. Okay. So when you make the load bit high, the system will get reset, and we can use the down counter. So this is about the down counter. Okay. So these are two cases of up counter and down counter. Next we shall discuss about up down counter that is present in the TIA portal. Okay. If you consider the up down counter, you can consider it as a combination of the up counter and down counter that we have discussed till now. Okay. Generally we find the applications of up down counter while counting the number of items that are present on a conveyor belt. Usually, if you take any conveyor belt example, I place one sensor at the input side and one sensor at the output side. And if I want to count the number of items that are present on this conveyor belt, then I can use the up-down counter. Okay. Okay. This is my up-down counter input. This is my up-down counter output pin. Not exactly output pin. See the down counter input. This is my reset switch. This is my load button. And this is my output. Okay. Now initially you can observe that in this example, this is the up count input signal and this is the output signal. So whenever if you consider the conveyor belt example, whenever any input is detected at the sensor, then the up counter input will be made high. Okay, so one item has been detected. Now let us assume that another item is also detected. When another item is also detected, the cumulative value is 2. So it indicates that the number of items on the conveyor belt are 2. Now when another input signal is being detected, the cumulative value has become equal to 3. So the total number of items on the conveyor belt are 3. The cumulative value over here shows the total number of items. Let us assume that one item has left the output of our conveyor belt. I have placed a sensor whose address is connected to the down counter input. So when one item leaves the conveyor belt, this pulse signal will become high and it will become low, and you can observe that the cumulative value has changed from 3 to 2, which indicates that one item has left, and the 2 over here indicates the total number of items on the conveyor belt. So this is how we work on the up down counter. So this is about the up counter, down counter and the up down counter. In the next lecture, we will be discussing few applications of counter programs. Okay.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.